right. So today we are still doing trigonometry stuff that I'm pretty sure that you did in geometry. Not positive, so correct me if you're wrong. And so we're leaving the realm of right triangles. Okay? We are moving on to triangles that are not right triangles. So you have to make sure you realize those things and don't try to do stuff we've already done in the past to learn your target. Okay? You can't do those things anymore. So the law of sines says that if you have any two of these ratios, you can set them equal to each other to write proportion and cross multiply to find a missing piece. All right. So it says that all three of these ratios are equal to each other. You just choose two that will help you in your problem to solve the missing pieces. Does that make sense? So you're not going to use all three together. Now I told you to get out your pre-calculus formula sheet that I gave you because you get that on the quiz and test. I've got laminated copies for in class, so I want you to be familiar with it. So if you flip it over to the pre-calculus side, which means I'm pretty sure the holes will be at the top of the paper. No. Yeah, see? All right, so the very first group on the left, I think, says triangles. And the very first thing in the triangle section is the law of sines. So not that this is really hard to memorize, but you don't have to memorize it. It's on the formula sheet for you to use. Okay? Does that make sense? All right. Then we are going to use the law of sines to answer a question. So we've got some triangle. Now, this triangle I drew does not mean we have this triangle. This is an obtuse triangle. Not all the triangles we're dealing with are obtuse. But I drew this just to remind you that angles are across from their corresponding sides. Okay, so remember that. That'll be helpful to you. Okay, so just keep that in mind. Now in Learning Target 12, we are solving the triangle. So we have to find all of the missing pieces. Okay, so for the first example, we have A is 40 degrees and B is 59 degrees, and it says that side C is 14 units. Well, as it is right now, with this information, I cannot use the law of sines yet. Because I would need two sides and at least one of the corresponding angles. And in this case, I have two angles, and they don't correspond with C. Right? I don't have angle C. But I know how many degrees are in a triangle, right? And I have two angles of the triangle, so I can find the missing angle. So you're going to have to do that first. Okay? So we know there's 180 degrees in a triangle. And so I need to subtract off with two other angle measures. So minus 40 and minus 59. I get 81. So angle C is 81 degrees. So now we definitely know that the picture I've drawn over here, just for reference, is not the triangle we're dealing with because all of the angles are acute in our triangle. Okay, so now that I have angle C, I can use law of sines. You could find side A or side B at this point. I'm going to go in alphabetical order, so I'm going to find side A first. You could find side B if you wanted to. So I don't know what side A is, but I know that that corresponds to angle A, so that goes over the sine of 40 degrees. And that equals side C, which is 14, over the sine of angle C, which is 81 degrees. So I don't even need the B stuff yet, right? I'm only picking the two ratios that will work for me. All right, so far so good? Then we just cross multiply. So I have A times the sine of 81 degrees equals 14 times the sine of 40 degrees. And I'll have to divide by the sine of 81 degrees to solve for A. So we're going to type that into our calculators. Again, make sure your calculator is in degree mode. So I get 9.1 units. It told me to round to the nearest tenth. Yes. You didn't. Did you divide? You have to multiply, you have to cross multiply. So do 14 times the sine of 40 first, but then to go back and divide by the sine of 81. Okay. All right, so everyone knows where I got 9.1 from. You need to fight the urge to use the Pythagorean theorem at this point. Pythagorean theorem only works for right triangles. We don't have a right triangle. So even though a lot of the times when you're doing trigonometry stuff, you're like, oh, I have two sides, now I can use the Pythagorean theorem to find the other one. You can't do that here. It won't work. You'll get the wrong answer. Okay? So we are going to have to do the law of sines again. You can use the side A that you just came up with, but I'll caution you, now that you've rounded that, you're going to get another rounded answer for side B if you use that. Okay? Because now you've rounded twice in the question. So use the same ratio we had before that we started with, but change the A stuff to the side B and angle B. All right, so if I do that, I have side B corresponds with angle of 59 degrees, so sine of 59 degrees, equals 14 over the sine of 81 degrees. So it's the same exact thing. I just replaced that first ratio with information involving side B. So cross multiply and divide again. So B times the sine of 81 equals 14 times the sine of 59. We'll have to divide by the sine of 81 to solve for B. So 12.1. Questions about where that came from? Okay then. I want you to do the second example. And then in a few minutes, I will tell you the answer to that one. You do the second one to practice. Okay, learning target 13. If you are given two sides and the included angle, so two sides and the angle in between them, so pretty much all the letters should be different. Two sides and an included angle. So remember from our picture, like two sides and an included angle would be two sides and the included angle. So it should be three different letters. Okay? Then you can find the area of a triangle without having to mess with trying to find the altitude and the base and doing half the base times the height. You don't have to do that if you have two sides and the included angle. Instead, you have this formula. But that formula, if you look in that same place on your formula sheet that I looked at earlier in the pre-calculus section in the triangles group, it should say area of a triangle, and it's there for you. Now, it does not list all three of them because you should be able to figure this out. The two small letters are the two sides, and the capital letter is the angle measure. If you're given two sides and an included angle, so all the letters are different, then you should be able to substitute to figure that out. Okay? So if we're going to find the area of the triangle down here, we don't need to draw it at all. You don't have to use half the base times height anymore, so you don't need the altitude or the base or anything. We just need to know two sides and the angle in between. So I've got 1/2 times 14 times 12 times the sine of 78.
Whoa. They just gave us everything. That's easy.
I know.
I love this.
It might give you two sides and an angle, but it's not the included angle, so you need to find another side first. Make sure you use the right information. So 0.5 times 14 times 12 times the sine of 78 is 82.2 units squared. So the formula is on the formula sheet. You can memorize it or anything like that. Again, on the homework, just make sure that you have, if you want to think of it this way, all different letters. You have to have two sides and an included angle. If you have other information, you might need to use the law of sines to find what you need to do the formula. Okay?